um, we need to consider practical approaches towards this reality, because not all effects that technology has are essentially good. Some of these can be quite damaging. So if we take, for example, technologies that make it easier for us to communicate with each other, they can equally cause something like filter bubbles. They can, if you look at online algorithms, they can cause the formation of very isolated knowledge communities and increasing polarization amongst different groups of people. And the same is true with regard to automated decision making, which basically affects more and more areas of our lives. And essentially, an algorithm could decide whether you get a job or whether you get a loan, or an algorithm can sentence you to time in prison. So all these new advantages, all these new changes come with a price, so to speak. Um, and this is already problematic as such in a way, but if we then also take into account that in a lot of the training data, we see different forms of bias that are inherent in the data and inherent in the systems, which only lead to further amplifying already existing inequalities. So, but fortunately, all of these developments have led to calls becoming louder and louder to actually develop these systems and algorithms in a more ethical way. So, as I said, theory is good, but we need theory to actually lead to practical changes, to changes in policy and to changes in how systems are designed. And there have been some really good suggestions, like there have been developments such as value-sensitive design and responsible innovation that really provide good and helpful guidelines as to how be more conscious and more aware when designing these systems. So basically what we need is a practical ethics that helps us make sure that AI systems are used ethically. And one approach, as I mentioned earlier, has been to draft different initiatives and guidelines. And I looked at different review papers, and this one of the most recent reviews by Roche, Wall, and Lewis, they analyzed more than 470 different documents that deal with different initiatives, AI ethics initiatives and guidelines. And they did that in 2021. So I'm assuming the number has only increased ever since. So commonly, these principles and guidelines usually focus around similar topics. They all kind of address legal, social, ethical issues around AI, things like data privacy, fairness, explainability, transparency, accountability, and bias. And these guidelines exist at both a transnational and a corporate level. So for example, one of the most prominent set of guidelines or rules was issued by the European Commission in 2019, and they basically identify 3 key features that new technologies should display. So the technologies should be lawful, meaning they should respect applicable laws and regulations. They should be ethical, meaning they should respect ethical principles and values, and they should be robust, both in a technical sense, but also considering the social environment in which the technology will be used. Similar guidelines or recommendations have been proposed by UNESCO and the UK government, to give just one example of a country and a governing body that has issued similar guidelines. So in 2019, they published something called Understanding Artificial Intelligence, Ethics and Safety. Also organizations like the IEEE, so the Institute of Electrical and Electronics Engineers, they put together a set of principles and guidelines to ethically design engineering systems. And as I mentioned, companies like Google have also developed their own AI principles. And most of these proposals have generally been welcomed as positive examples, positive first steps. But several reviews have also voiced criticism. So it has been found, for example, that looking at all of these different guidelines, they basically focus on concepts of ethics that are prevalent in the global north. Countries in the global south are overall underrepresented. There's usually a lack of diversity in all of these guidelines and initiatives. So it has been noted that there is generally a need for more diversity and intercultural awareness. And also a very important aspect is that they do not really consider what the development of new systems mean for different countries and people all over the world. So how do systems that, for example, are developed in the global north affect countries and peoples in the global south? So this disproportionality is not really addressed in these guidelines. So basically, unfortunately, these guidelines do not really automatically mean practical change. They can only really lead or be action guiding towards practical change. And some of the most frequent criticisms has been that these guidelines are generally very abstract, very high level, and don't really address specific examples. And we need specific examples in order to draft specific policy changes. Some other criticism has been that basically if you look at AI as a field and AI practitioners, it is not really a formal profession yet. There is no professional history. There are no shared norms. If you compare that, for example, to other fields like medicine, where there's a long-standing history of the professions and the shared norms that should be valued and respected. So such a thing doesn't yet exist in the field of AI development. Also, these principles are a matter of interpretation. So, for example, privacy can be understood or is understood differently in different countries. What is considered fair is understood differently in different countries and by different people. And some of these principles are also in conflict with each other. So if you look, for example, at medical diagnostics, some of these systems are really good at detecting cancer at an early stage, but we don't really understand how these systems fully work. So one of the requirements for the system to be explainable is not met. So the benefits kind of conflict with the downsides, namely that the system is not fully transparent. So it has mostly been demanded or criticized that instead of looking at all the similarities that we have or the shared values that we can agree on, we should focus more on the tensions and the differences and look at those and try and figure out how to address those and solve these issues. So the next thing I want to look at in a bit more detail is the aspect of interdisciplinarity in the field of AI ethics and why I think, or not just I think, but personally I think it's really important to work interdisciplinarily if you can in this area. Yeah, and I want to again start with an example that also relates to my own work that I'm going to talk about in just a moment. These are all headlines from around 2018, where people started noticing that Google Translate was showing sexist results for certain translations, especially when translating from a gender neutral language into English or vice versa. So this is an example from Google Translate trying to translate from Turkish, which does not have gendered pronouns, so it only has gender neutral pronouns, into English, where we do have differently gendered pronouns like she and he. And it would always assume for doctor that it's a man, and for example for nurse that it's a woman. They've now made some changes so that at least you're given a choice. You can select yourself if you want the pronoun to be male or female, as you can see on the right-hand side. But yeah, why I'm basically showing this is to illustrate you need to talk to linguists, essentially. If you want to work in natural language processing, I feel like you cannot even expect someone who does all the coding to know and understand all the different languages and the issues that might arise when automating translation. But you need to talk to linguists in order to kind of avoid these problems. So interdisciplinarity in ethics is required, as Kazim and Koshiyama also say. It is required, and yeah, basically, I can just read out the quote. So digital ethics is a highly interdisciplinary field requiring expertise that spans the sciences and the humanities. Yes, and I want to just illustrate that it's basically already naturally happening. So we have AI that, of course, influences a lot of other fields naturally by its developments, but also vice versa. So a lot of developments in other fields make AI improvements possible. If you look at physics, any developments in physics could potentially improve AI, such as in the field of quantum computing. Legal regulations impact the implementation of AI, for example, as we saw in the General Data Protection Regulation in the European Union. Social sciences, so AI should be used to improve the human condition and not aggravate existing inequalities. In education, we see it in two different ways. So AI is used for teaching, so AI needs to be developed specifically for those conditions. But we also see an increasing demand for teaching digital literacy to students. And then, of course, you have ecology and thinking about how new AI developments are impacting the environment. One of the proposals that were made by Kazim and Koshiyama was basically three different scenarios of making interdisciplinarity work in AI ethics. One would be co-design, which basically means that during the designing process, ethicists or non-technicians are already part of the team. So basically, the whole design process is already interdisciplinary. Another idea is that having clear principles, standards, guidelines is enough. We've seen, of course, that the idea of having shared principles can be really difficult. It can be difficult to find consensus, and guidelines can be ambiguous. And another scenario is that if there are trade-offs or trade-offs need to be made, that they are clearly justified and articulated and explained, basically. So I think I would personally say, and I think there is a lot of agreement, that the first scenario would be the most successful and the most promising. And this has also been proposed in the form of what is called embedded AI ethics. So the idea that um, social, ethical, and legal issues are already, or like the practice of addressing potential issues is already integrated into the whole design process. So from planning basically through designing, programming, onto testing, and finally implementing the system. At every step of the way, ethicists or social sciences or legal expert would be included in the team or would be consulted to discuss potential pitfalls and like scenarios that could happen. And the gold standard is, or would be, that an ethicist, at least one ethicist, is a permanent member of the team. But the least thing that should be accomplished is to have a regular exchange between technicians and ethicists or social sciences. Of course, ideally that on behalf of the ethicist, that would also require a bit of domain-specific knowledge and understanding. So to know a little bit about the systems that are developed and what they will be used for. But this essentially already implies collaborative work and interdisciplinary openness. Yes, and now I want to look at one specific example. Oops, I'm sorry. From my own research, my own work, and that is gender bias in machine translation systems. So I already showed the headlines in the example just a moment ago. So the problem is that you will probably know that different languages have different grammatical genders that can be realized in the form of pronouns, but can also affect the different forms of a noun. So if we look at English and German, for example, if you see on the right-hand side the sentence, the nurse called the doctor, if you want to translate that sentence into German, you have to make a choice between male and female. And the default translation that Google, for example, uses is the nurse is female, the doctor is male. And that, of course, has to do with the training data and with the methods of how this training data is obtained, because it is largely internet data and a lot of stereotypical and imbalanced gender representations are still found in those data sets. So of course, if these biases are in the training data, we just blindly train the system, we will see these stereotypes and imbalances in the outputs. So a little bit more about the data set that we worked with in this project. So again, unfortunately, this was internet data. We worked with over 17 million sentence pairs in English and German. The data was scraped from the internet. The advantages are, of course, that this is a relatively quick and easy and also cheap way of obtaining data. And it usually means that we have a variety of different registers. So formal language, but also informal language, slang, and even archaic words. So in our data set, for example, there was also quite a large proportion of religious texts. And so what I did as a first step was I took a subset of that data set. So I looked at roughly 5% of the whole data set, and I did a corpus analysis, and I looked at the distributions of differently gendered words. So here you can see an example of that. I've marked some of the most interesting results in red. So you can already see, if you look at the distributions of he versus she, that the male counterpart is a lot more frequent than the female one. But sometimes it's also the other way around. So in some instances, such as husband and wife, we have the female counterpart being much more frequent. And this has to do with the large amount of biblical text. This is the same in the German translations as well. So wife is used a lot in the Bible, in English and German translations of the Bible. And yeah, you can see that in the results. Boy and girl also show skewings more towards the female counterpart, and this can actually also be explained by the data itself. If we take a look at this, you can see the different collocations of girls. So what other words tend to occur in the vicinity of this word. And unfortunately, again, this is internet data, internet text. Unfortunately, a lot of these contexts are sexualized, so leading to the fact that girl is a lot more common in this data set than boy. Yes, another example we looked at, or I looked at translation pairs. So for example, and these are very stereotypical ones, I have to admit that. So I used pairs that where you basically already have an idea of what the stereotype might be. So again, doctor, the stereotypical expectation would be most doctors are male, which is not the reality anymore, absolutely not, especially in Germany. But in the data, you can see that the male component or the male translation of doctor is a lot more frequent. And if you look at nurse, for example, the female translation is a lot more frequent. So what do we basically do with this, or what did we do with this? This raises some questions. One of them would be, can we completely get rid of all these biases in the translations? And the other question is, of course, should we get rid of all these biases? Would that be a fair and realistic representation of the distribution in society? So certain imbalances are, of course, realistic. They actually reflect situations or how the distribution is in the population, but others clearly do not, and they do lead to stereotypes and to discrimination in real life. So one thing to say is we cannot get rid of all biases. This is basically impossible, especially if done manually. And again, we can think about whether that's desirable or not. But we tried different methods before and after training the system to see if we can at least reduce the level of bias in the results. So one of our PhD students in engineering, she tested different scenarios, 3 of them before training the system. So she tried downsampling and upsampling the data and then counterfactual augmentation. So downsampling basically means that all the data was removed until there was a balance for both languages in gender terms. So removing data until a balance is reached, and upsampling would be the opposite. So we duplicated data until a balance for gender terms was reached. And counterfactual augmentation basically means that we automatically introduced counterfactual sentences that included the underrepresented gender terms. So if there was a sentence like, he is a doctor in the data set, but not the female version, we added this female version. We added the sentence, she is a doctor, to balance it out. Yes, this didn't really lead to any noticeable gains, neither in accuracy nor in quality of the translations. It also really didn't reduce the bias. So this turned out to be quite ineffectual. And also, it is really difficult truly getting rid of all the biased forms, especially if you consider individual complexities of the different languages. So what we then tried was to remove bias or mitigate bias after training the system. So the system was trained on the entire data set first, so all these 17 million sentence pairs, but then we created a very, very small sub data set or sub corpus which we then used to fine tune the system again. So we call this tiny because it was literally tiny compared to the original data set. We only had 388 sentences, and these consisted of very simple sentences that all had the same structure, something like the engineer finished her work. All of the sentences were similar to that, and they included 194 professions, and then of course the gendered forms and the gendered pronouns respectively. So yeah, the system was trained on the large data set and then retrained on the tiny data set. And this actually reduced the bias, and it was comparatively more successful in reducing the bias. And it kind of, it presented, or it showed us a more or a more ethical way of mitigating gender biases in the outputs of automated translation. So as I said, it is impossible to get rid of all biases, but this kind of fine-tuning method or domain adaptation method showed that we could at least reduce it in a considerable way. So this is basically, from my very own experience, an example of how we achieved this working interdisciplinarily within the group. So some of my colleagues provided the theoretical background, the ethical criticism, and the philosophical foundations. So basically providing the theory and the non-empirical part. And then I, as a linguist, I performed the analysis of the sample data set. I looked at both of the languages comparatively. I performed corpus analysis. And then in the practical phase, we had engineers or information engineers specifically who actually used all of this knowledge, all of this theoretical knowledge to then test different experiments, which resulted in what I just explained. And now I'm not sure. Yeah, I think I'm going to stop here. I'm going to skip this example. I'm just going to very briefly conclude that basically what I've talked about is that AI technologies have created challenges that require us to reconsider and to differently apply ethical and philosophical theories. We definitely need practical ethics, though theories are not enough. And ideally an embedded ethics approach in all phases of AI development. And I believe collaboration and interdisciplinarity is the future and is essential to really fully address any kind of social, ethical, or cultural issues that are created by AI systems. Okay, I'm gonna stop here to leave some time for questions. Thank you so much for listening.
Thank you, Stephanie. That was a very informative talk. So now we have 15 minutes, 10 minutes, 15 minutes for question and answer. So if anyone have any question for Stephanie, please feel free to unmute yourself and ask the questions. Okay, so people probably still thinking about your talk and what question to ask you. So I will have a question. I will ask my question first then. Thanks very much. And I think that was very good to see where linguists can contribute in technology-related research. And I just have a question for you, because you've been doing a lot of these collaborative projects with people from engineering, people from technology, philosophy, and also different disciplines. What is your actual experience in working with a team like that? Because I think that we all know that collaborative research is really beneficial. But from my own personal experience as well, it's quite challenging to work in a team like that, particularly with people from engineering and technology, because they don't really see the value of linguist and linguistic skill in a project that heavily based on application and the output. And, you know, at the end of the day, they want to be able to deliver a product, a technical product that do what they want. And so not many people really see, it's not immediately obvious to them the value of the linguistic skill that we bring in. So if you can share a little bit more about that experience and how you deal with that during the process of collaboration, I think that'd be really helpful.
Mm-hmm. Yeah, that's a good point. And I have to admit, maybe first of all, that I was nervous at first as well, because I thought I don't have a very profound technical understanding of how things work. So I was kind of unsure of how to work together with engineers, with computer scientists. But then I also noticed, when starting to talk to them, that they, of course, also don't have a very profound, or not all of them, a very profound linguistic knowledge. So there's also, we can both learn from each other. And so far, I think, so we've worked, as part of this project, we've worked a lot with students. So students who are getting a master's degree or a PhD. And they've been really interested, particularly in projects that have like a real life component. They can actually see how it affects their own lives, such as social media or translation. And they've been really interested in actually getting involved with this. And I understand that it's not everyone is the same. People work differently. Some people might not really be interested in working collaboratively with other fields, but I think it's worth trying. And it turns out that more people than you think are actually quite open to doing this and quite open to learning new things and making things better. I think hopefully we are kind of reaching a point where people understand that you cannot work in isolation anymore, that these technologies affect so many different areas and tend to affect them so negatively that you really and you cannot be an expert in everything. Like, you cannot be an expert in computer science, in linguistics, in philosophy. So ideally, more and more people will be more open to working with colleagues from different fields. But I feel like it's changing, it's improving, definitely. But I also understand, I just want to add this, I also understand that it's not equally possible for everyone. So it depends on different countries, it depends on the institution, it depends on your managers and your PIs, and how much time people are willing to invest. So I understand that it's not as easy for everyone.
Yeah, I totally agree. And I think it really depends on where you are and the institution and the resources available to you. I'm not sure if maybe someone in the audience can share the experience of doing collaborative research in your domain in Vietnam. Obviously, it's very different. I don't have a lot of experience working in Vietnam either. So maybe if someone here who already done similar project might share that experience, that would be really helpful.
Yeah, I would be really interested in hearing that, because I talked to someone from Hong Kong once, and he said it was quite difficult for him to actually work interdisciplinarily with other colleagues because there wasn't enough funding, there wasn't enough time. Um, so So it would be really interesting to hear the perspective from another country.
Yeah, anyone here? Anyone here willing to share the story of working collaborative in Vietnam with Dr. Stephanie? Or if you have any other questions for her.
Okay. All right. Thanks for your sharings, Dr.